we've got to be showing a lot of our working in this question. We're given a sketch of this function for x greater than 0 and asked to find the exact area shown, giving our answer in the form a root 2 plus b. Right, well, first up, we can find where the graph is equal to 0. And we can times through by 4 root x. It's going to be when the x minus 2 times x minus 4 is 0. So it's going to be 2 and 4. We've got our limits for our integral. Okay, now how to integrate this? Actually, in the answers, they write in one way they do it by parts. Um, it looks pretty complicated, to be honest. And the second one they do a substitution. I'm going with neither, and I'm gonna actually just expand things out. So y is going to equal x squared minus 6x plus 8 all over 4 root x, which is x to the half. And actually, this is one that you could do in the first year. You can bring the quarter out and then do x squared divided by x to the half, which is going to become x to the 3 over 2. They're all in the form x to the n, is all I'm saying. It's a tough question, but it still, doesn't require integration by parts and so on. Then minus 6 x to the half, because it's x divided by x to the half, remember that's x to the 1, plus 8 x to the minus a half. Okay, I'm going with that. So okay, this is gonna give me a negative area. By the way, I'm gonna swap the sign at the end. But I think I'll just remember to swap the sign. I could put a negative. Do you know what? Let's do it. R is going to equal minus the integral of 2 to 4 of a quarter x to the 3 over 2 minus 6 x to the half plus 8 x to the minus a half dx. Now, one thing you can do is swap the limits. I'm going to take the quarter out and swap the limits around because that deals with the negative bit. When you have the integral of BA is equal to minus the integral of AB, because you're substituting A into whatever you get as your function and minusing B, instead of doing B minus A, so that you can see they're going to be like just the negatives of one another. And by the way, you can just ignore all this and just make it negative at the end. It just feels like it's quite easy to forget. Okay. So raise the power by 1, divide by the new power. Raise the power by 1 times by 2, 2/3, which is going to give me 4. Of course, you can use your calculator to help you with this if you want. And then raise the power by 1 to a half, divide by a half is going to give us 16. Okay, maybe this is where integration by parts and substitution might be a bit nicer because I got substitute 2 and 4 in. Remember, I can't just stick this in my calculator because I need to leave it all exact. And I'm not sure our calculator can deal with, say, 2 to the power of 5 over 2. See, straight away you get decimals, but it is achievable actually. So what I can do is write it as x to the half to the power of 5. Therefore, I'm going to get 2/5, and then it's going to be root 2 to the power of 5 minus 4 root 2 to the power of 3 plus 16 root 2. And then I'm minusing, put this in a big bracket, 2/5. This one's a bit nicer because I can square root 4. I'm actually going to get 2/5 times 2, but it's root 4, isn't it, to the power of 5 minus 4 times 2 cubed plus 16 times 2. Now, root 2 to the power of 5, root 2 times root 2, so that's root 2 squared is 2. If I do it 4 times, see, I'm going to get to 4. So root 2 to the 5 is going to be 4 root 2. root 2 cubed is going to be 2 root 2. It's going to be minus 8 root 2 here. And I think we get away with using a calculator for the 4 bit. So 2/5 times 2 to the 5 minus 4 times 2 cubed, which is actually just 8, plus 16 times 2, which is 32. This gives 64 over 5. Okay, I'm very nearly there. Again, I can use my calculator to help me with the root 2 bit because I'm just adding lots of root 2's now. So I've got 2/5 times 4 lots of root 2 minus 8 lots of root 2 plus 16 lots of root 2. So I've got 48/5 lots of root 2. And I'm minusing 64/5. Divide each term by 4, I get 12 over 5 root 2 minus 16 over 5, which is, as was asked for, leave it in the form a root 2 plus b, where a and b are constants to be found. I have that. There is our solution. All right, it's a bit very easy to make mistakes, I think. A bit tricky, but there we go.